Hello everyone. These many days we are discussing about some mathematics related topics. Now today first time let us discuss one science related topic, that is electricity. Most of the students face problem in solving numericals in electricity. So today let us see what are the basic definitions, basic formulae, important formulae, and how to solve some numerical problems in electricity. Now let us see first what are important definitions in the electricity. First one is current. You have to know what is current. Current is defined as rate of flow of charge. What is rate of flow of charge means? The flow of charge per unit time. Flow of charge per unit time will be called as current. How much amount of charge is flowing through the circuit in unit time will be called as current. So you have to know current is denoted by I. So I is equal to charge per unit time. Charge is denoted by Q. So Q by time. Time is T. So this is the first important formula in electricity. I is equal to Q by T, where I denotes current. I is current, where I is current, Q is charge, and T is time. So here you need to note the definition also. Definition we have seen, I is equal to Q by T, that is formula is I is equal to Q by T, that means rate of flow of charge is defined as current. Here let us see what are the units of these three terms. Current units are amperes. Units also you have to know, current units are amperes. We know charge units are coulombs, it is denoted by C, and time units already we know, that is seconds. This is about first important formula. So by using this formula, whatever problem comes related to current, charge, time, we have to use this formula, first formula. Now coming to second one, second important definition you have to know, that is voltage. Voltage is also called as potential or potential difference. What is potential difference or voltage? Potential difference or voltage is defined as, potential is different, potential difference is different. So that is potential is, it is the work done to bring a unit charge, work done to bring a unit charge from infinity to a point. That is called as potential, whereas potential difference is work done to move a charge from one point to another point. Work done to move a charge from one point to another point will be called as potential difference between those 2 points. It is defined, it is denoted by V. Potential difference is denoted by V, and the formula is V is equal to W, where W is work done per charge. Charge is denoted by Q. So this is the second important formula in electricity chapter lesson. So here V, already I told you just now, V is what? Voltage or potential difference between 2 points, and W is given by work done to bring the charge, and Q is what? Charge. We know here also units, voltage units are joules, and work, 1 minute, sorry. Here voltage units are volts, work units are joules, whereas charge units already we have seen coulombs. Now coming to third important definition, that is resistance. Here this formula comes, we derive it from a law, Ohm's law, derive it from Ohm's law. What is Ohm's law states? Ohm's law states that at constant temperature, the potential difference across the circuit is directly proportional to current flowing through the circuit. Potential difference across the circuit is directly proportional to current through the circuit. That means what? Whenever we apply more whenever there is more potential difference, there will be more amount of current through the circuit. If there is less amount of potential difference, then less current will be there through the circuit. So by this what we understand, V is directly proportional to I. From this we write V is equal to IR, where R is proportionality constant. Here this is one more third important formula that we have to remember in electricity lesson. Here again, as usual, V is what? Voltage, whose units are volts, and I denotes current, units amperes, whereas R is new one now, that is resistance. What it is? Resistance of the conductor, and the units of resistance are ohms. So V is equal to IR. So this is the third important formula. Now comes to third one, that is power. Generally, what is power? Power is defined as rate of doing work, means in how much amount of work you are doing in certain time. If you do more work in less time, that means what? You have more power. If you do less work in more time, you have less power. So power is defined as work per unit time. That is what? Work by time. Okay. So here in this topic we have power is equal to voltage into current. Voltage into current. Why voltage into current it is? Because we know V is W by Q, whereas I is Q by T. So finally what we get? W by T only. So what? Voltage into current is nothing but work per unit time only. Voltage into current is nothing but work per unit time. So by this you should understand, now onwards in electricity generally power is what? Work per unit time, that is W by T. But now in electricity you remember power is equal to V into I, potential difference into current. Hope you understood why we are writing power is equal to V into I, because V into I after simplification we get that is nothing but work per unit time only. And here what are the units of power? We know already what is V here. V is voltage and units are volts. I is current, units are amperes, whereas P is new thing, that is power. Power units are watts. Watt. Right. Now the next definition, that is energy. What is the difference between power and energy? Rate of doing work, means with respect to time. The rate of doing work will be called as power, whereas energy is what? The capacity of doing work will be called as energy. Energy is defined as, we already know just now, power is equal to work into time. Here work is nothing but energy. So by this what we can write? Energy is equal to, energy is nothing but work only. So here what we do? Energy is equal to power into time. Power into time. So here I forgot to tell you one more. What V, it can also be written as V into I. In other terms, how can we write? V into I, we already know V is equal to IR from here. So if you write IR into I, which is I square R. So what? Power can also be written as I square R. Similarly, we can substitute I as V by R. So we also get V into V by R, which is V square by R. So for power, how many formulae we have? One is these many. These all you have to remember, so that according to the given question you can substitute. One is work per time. One more, power is equal to V into I. one more, power is equal to I square R without V. If you don't know V, you know only I and R, you have to use this formula. Similarly, P is equal to, power is equal to V square by R also we can use. This we have to use whenever there is no current. You know voltage and resistance, then you need to find power, then you have to use this last formula. Now all these power values, if you substitute in energy, we get in this way. One is P into T directly. We also know power is equal to V into I. So V into I into T also you can write energy formula. And one more, what? We also know power is equal to I square R. So we can also write it as I square into R into T. Here power is I square R. And one more, we also know power is equal to V square by R. V square by R into T. This is one more formula to find energy. So these all are what? Formulae to find energy. So what you have to know, basic formula, E is equal to P into T. That is, energy is equal to power into time. Here basic formula, power is equal to V into I. So by this remaining all you can remember. Here voltage is equal to I into R. Here voltage is equal to W by Q. Here I is equal to Q by T. So these all, better if we list out one chart like this, it will be good. You can remember formula easily. So here we have a chart, voltage, we also write it as potential difference, it denoted by V, and units are volts. And you can write a formula also, V is equal to, basic formula is what? W by Q. And power, how many we wrote here? Formulae, power formulae we wrote many. So let's discuss how to remember the formulae. One, to remember voltage, we have two formulae. One is V is equal to W by Q when work and charge are given. One more also we have, that is V is equal to IR. V is equal to IR is another formula. Let's write here better. V is equal to W by Q, and one more, V is equal to IR. These are the two formulae to find voltage. Next, power, main important formula I am writing. And here power, we have power is equal to V into I, one formula. Power is equal to I square R. Power is equal to I square R. That can also be written as V square by R. Yeah, these are the main important formulae to remember about power. And one more basic formula also I told, that is work per time, rate of doing work. Charge, we have first formula, what, that is what? Q. First formula is what? I is equal to Q by T. From this only we can write Q is equal to I into T. This is the formula to find charge. Now energy, work or energy, both are same. I told you important formula is what? Power into time. From this we can remember all the remaining. That is I square RT, V square by R. All these you can remember. Or V square by R into. These are formulae to find energy. Resistance, here we have, I forgot to tell you one more. What? One formula we have resistance related. One is what? One basic formula we know, I is equal to, V is equal to IR. V is equal to IR. From this we can write R is equal to V by I. Other than this we have one more, that is resistivity. Resistivity is denoted by rho. Okay, so here when we know rho, we have another formula, length, area of cross section, and rho, we have another formula, that is R is equal to rho into L by A. This is also one important formula only. You have to remember this also, R is equal to, and here current I is equal to Q by T, one formula, and I is equal to V by R. Next, resistivity. Yeah, here it came. Resistivity, from this formula only we find resistivity also. What is resistivity? Rho is equal to R into A by L. Just transpose L by A this side, will become A by L. These are some important formulae that you have to remember to solve numericals in electricity. Yeah. So if we want, you can list out all these in the chart or in a table so that you can remember all these better, and when question comes you can select correct formula to solve the problem. Now let us see next important topic what we have. So these are what symbols. You should know about symbols also in this topic. Which symbol is what? This is first one is what? Electric cell, single cell, and the second one is what? Battery. When series of cells are used to get more energy, when you want more potential difference, more voltage, we need to use a series of cells. Series of cells is nothing but battery. So this is what second one is battery symbol, and here it is what? First one is plug key. This is closed plug key. If you don't have that dot inside, that is open plug key, and here open switch. If these two are closed, they will be called as closed plug key or closed switch. Here we have already that also. This is open one and this is what? Closed one. These two are used. You should know functioning of all these components also in the circuit. First one is what? Battery. What battery will do? It gives the energy to the circuit. It is called as source of energy in the circuit. And the second one is what? It is used to open the circuit or to close the circuit. When you open the switch, a circuit will be open. When you close the switch, circuit will be closed, so that electricity will pass through the circuit. Next one, joint. This is what? A wire joint. This symbol is wire joint. Next one is what? Bulb. So whenever you want to represent a bulb in the circuit, in this way you have to represent. This is what? Resistance. Resistance symbol. You have to know resistance symbol also. This is also a resistance, variable resistance, but what we can change the value of the resistor here. So according to the requirement, we can take the resistance. If you want to increase, or you can increase, or if you want to decrease, you can decrease. So we also call it as rheostat. Rheostat, variable resistance. Anyway, any one you can call, and any one of these two symbols you can use. This is what? Ammeter, one of the important device that you have to know. Ammeter is used to measure current in the circuit. Ammeter is used to measure current in the circuit. It is connected in series with the device. So you remember, this is important. Ammeter is used to measure the current, and it is connected in series with the device. Second one is voltmeter. Voltmeter is used to measure voltage or potential difference across the device, and it is connected in parallel with the device. So voltmeter is connected in parallel, whereas ammeter is connected in series. These two we have to remember. So this is what? One simple electric circuit that you have to know. In simple electric circuit, what we need? One battery we need, source of energy, then connecting wires to transmit the energy, that is charge. Next what? Switch. One switch we need to open or to close, and one consumer of the energy, that is what? Bulb or fan, whatever device. Next, this is what? Schematic diagram of simple electric circuit. In this way we have to represent. This is what? Circuits, components, and the circuit diagram, simple circuit diagram. Let us see next important topics what we have. So this is what? How we connect ammeter and voltmeter in the circuit. See, ammeter, just now I told you, ammeter will be connected in series with the device. So here this is what? Our device. This is called series connection, one terminal to another terminal, positive to negative. Again, this type of connection will be called as series connection, whereas voltmeter will be connected as parallel. Parallel means what? All the terminals, one side terminals will be connected at one point, and other side terminals will be connected at another end. So this type of connection will be called as parallel connection. See here, these two terms are terminals are connected at one point, other side two terminals are connected. So that is what? Parallel connection. So you remember voltmeter will be always connected in parallel, ammeter will be always connected in series. Ammeter is used to measure the current, voltmeter is used to measure the potential difference. This is what open switch. If you close the switch, what will happen? Current will passes through the circuit and bulb will glow. This is about schematic diagram, and here you can observe how this ammeter and voltmeter will be connected. This is what here ammeter is connected with this device in series, this is what switch. This is switch. When you open the switch, current will passes through this device. So through this device it is connected in series. Whereas here one more device we have, that is bulb. Through bulb what we connected? Voltmeter we connected. Voltmeter is connected in parallel. You can observe these two terminals are connected at one point and these two terminals are connected at another point. They both are not like one after other. Okay, that is what parallel connection. This is voltmeter and this is ammeter connection we can see in these two figures. Now coming to resistors in series and resistors in parallel, this is also important topic in electricity. Here the derivation and the formulae in resistors in series, resistors in parallel you have to know. This is what series one, first one, series combination. Or connection of resistors. Okay, this is series connection. In series connection you have to remember one thing, that is in series connection current will be same across each device. Current across each device is same. See, we have 3 resistors. At every resistance current value is I only. But if you observe, voltage is divided at across every device. Means total voltage, if it is V, at R1 it will be V1, at R2 it will be V2, at R3 it is V3. So in series connection what you need to remember, voltage is divided, current is unique. When voltage is divided, you have to remember voltage will be V is equal to effective, that is what total voltage is equal to V is equal to V1 plus V2 plus V3. Now we know V formula. What is V? I told you just now to remember all these formulae. V is equal to IR. So we can write IR is equal to, at resistance 1 voltage is V1 and current is I. So V1 is what? V1 is IR1 because current across R1 is I. And current across R2 is what? I only again. So I R2, this is what V2. I R3, this is what V3. So V, V1, V2, V3. So V value, V1 value, V2 value, V3 value we have to substitute in above equation so that we get effective resistance. I is equal to R is equal to IR is equal to, we should take I common. After you are taking I common, it will become R1 plus R2 plus R3. So after cancellation II, we get R is equal to, R1 plus R2 plus R3. This is also one of the important formulae in electricity. This also you have to remember. Resistors in series connection. Now let us see resistors in parallel connection. Parallel connection of resistors. So here what important thing you have to remember, you can observe the figure here. What is same? Here voltage is same at every device, but current is divided. After it is coming here, it will be divided as I1 and I2. This side it is coming I1, this side is what? I2. Again after it is coming, this I2 will be divided as again I2 and I3. Here it is I2 and this is I3. Let us take this total current in the circuit is divided as I1, I2, I3. Now If you take it as I1, I2, I3, like before, we have to take now I, because I is divided. So I is equal to I1 plus I2 plus I3. Now we know how we wrote V is equal to IR from the same formula. Now we have to write I is equal to V by R. Now it is V by R. This is V by R1 plus V by R2 plus V by R3. Now if you take V common here, V by R is same as usual here. Here if you take V common, it will be 1 by R1 plus 1 by R2 plus 1 by R3. So here what happens? V we can cancel. So finally we get effective resistance 1 by R is equal to 1 by R1, 1 by R1 plus 1 by R2 plus 1 by R3. This is the formula to find effective resistance in parallel connection. Hope these two derivations you understood, and you need to remember this formula also. Very important. Okay, done. Now let's see next topic, next important topic what we have in this. Now coming to problems. First problem, when a battery is connected across an unknown resistor, there is a current of 100 microamperes, 100 milliamperes in the circuit. The value of resistance of the resistor is. So here what? Which formula we have to use? That is important. Selecting the formula is important. One is 4 volts it is given, and other is 100 milliamperes it is given. So 4 volts and 100 milliamperes means what you should know? You have given V value 4 volts, and you also have I is equal to 100 milliamperes. Current also we have. So before you are doing problem, let us make it into amperes, because that is the standard unit. So milli means you have to know. Milli means 10 to the power of minus 3. Milli means 10 to the power of minus 3. Kilo means 10 to the power of plus 3. Okay, so here what? We can write it as 100 into 10 to the power of minus 3 amperes it is. Okay, let us remember that. Now we have to use the formula. We know V and we know I. We have to find R. So which formula we have to use? We know V is equal to IR. This formula we have to use, because we know V and I, we have to find R. Now here V is equal to what? 4 volts is equal to I. I is what? 100 into 10 to the power of minus 3 into R. Now we want R value. So what? R is equal to 4 by 100 into 10 to the power of minus 3. That is 4 by 100 is what? Okay, let's write 100 as 100 only, but 10 to the power of minus 3 means 1 by 1000, you remember. Okay, 1 by 1000. Now what we can do? 0, 0 here, 0, 0. So that is what? 4 by 1 by 10. That is what? 4 into 10. 4 into 10 is what? 40 ohms. 40 ohms. If you want to do it more simple way, I will tell you another way. That is what? We can write it as 4 by 100 into 10 to the power of 3. This minus 3, when you transpose up, will become 10 to the power of 3. That is 4000, because 10 to the power of 3 is 1000. 4000 by 100. So here 0, 0, 0, 0 cancel. That is again 40 ohms. In this way also you can do whatever method you feel easy, that you can follow. But you have to remember, formula to be used is V is equal to IR. Now coming to second problem. In this problem, what you know? One is current 2 amperes and other is 10 ohms resistance. Here two problems are there. Let us do the first one. In this, what we have to find out? Energy we have to find out. What we have to find? Energy we have to find. What information is given? Time is given, current is given, and resistance is given. So let us find A, first one. You know formula E is equal to many we wrote. Energy, one is power into time, but you don't know power here, and one more because power is nothing but V into I into T. That's why you should remember this basic formula, then one after other all you can remember, remaining also you can write, from that you can solve easily. Now we know current and time, but we don't know voltage. Still this formula is not enough. We want formula only in terms of current and resistance. So voltage should be expressed in terms of current. So what it is, V is nothing but I R into I, that is I square into R. So now I square R is the formula, into time. Here we forgot to write time. 1 minute. So I square R into time. This is V into I into T. So IR, I is what now? 2 amperes into R is what? 10 into again I is what? 2 into time. Time is 30 minutes. So 30 minutes should be changed into seconds, because standard unit is what generally we use, seconds. So 30 into 60. 30 into 60 is what? 1800 seconds. 1800 seconds. So what we get here? 4 into 18,000. 18 fours 72. 72,000 joule per. Okay, only we want units are wrong. It is energy. So what it is? 7200 joules. 72,000 joules. 72,000 joules it is. That is what, how to find energy. And the second one, calculate the amount of charge that would flow in 1 hour through the element of an electric iron drawing a current of 0.4 amperes. So in the B, what we know, again what we have to find? Charge we have to find. In the second one, charge we have to find. What information is given? We have to find charge. What information is given? 1 hour. Time is given. And one more, current. Current is given. So what formula we have to use here? Here we know formula, first formula only. What is first formula here? I is equal to Q by T. I is equal to Q by T. From this we can write Q is equal to I into T. So here I is what? I is given as 0.4 amperes into time is given as 1 hour. Again 1 hour should be changed into seconds. You remember 1 hour is equal to 3600 seconds. 60 into 60, 3600 seconds. 3600 seconds. So what it is? 3600 into 0.4 is 360 into 4. 360 into 4. It is 0.1440. So what it is? 1440 coulombs. This is what? The solution of the second one. Hope you understood these two problems. Now next one. Two resistances of 4 ohms and 8 ohms are connected in parallel. What would be the combined resistance of the system? So here what we have to use the formula, whenever resistors are connected in parallel, formula is 1 by R is equal to 1 by R1 plus 1 by R2. That is 1 by R is equal to 1 by 4 plus 1 by 8. And here they both are not like fractions. We need to make them like fractions. So we need to take LCM. LCM of 4 and 8 is 8. So we have to write it as 1 by 4 into 2 by 2 plus 1 by 8. No need to multiply anything because it is already 8. So what it is? 2 by 8 plus 1 by 8, which is 3 by 8. So what we got? 1 by R is equal to 3 by 8. Therefore R is equal to 8 by 3 ohms. If you want further answer, you have to divide. R is equal to 3 ones are 3 twos are 6. 0.2 will be left. Again 2 6 2.66 ohms. So we can write it as, if you make it round off, it will be 2.67 ohms. 2.67 ohms, 66 bar ohms, or R is equal to 2.67 ohms. This is what the parallel combination solution. Hope you understood this. Now this is one more, fourth one. Two identical resistors, each of resistance 2 ohms, are connected in series first time, and then parallel second time to the battery 12 volts. Calculate the ratio of powers consumed in two cases. So here this type, slowly we are going into some complicated problem. So here what power ratio you have to find out in two cases. So let us take first case. In first case what we know? We know resistance, we know 2 ohms. Two resistances are 2 ohms only. R1 and R2 both are 2 ohms. These two are connected in series. So let us find out effective resistance, that is R1 plus R2. Effective resistance is 2 plus 2, that is 4 ohms. In the first case, effective resistance R is equal to 4 ohms and V is equal to 12 volts. It is given. V is equal to 12 volts it is given. We have to find power. So what is the power formula? When you know V and R, you have to remember V square by R, direct formula. So what it is? V square is 12 square by 4, which is 144 by 4. After cancellation we get 36 watts. This is the power in the first case. Now take the second case, power in the first case. Now second case, R1 and R2 are same. R1 is equal to 2. R1 is equal to 2 ohms. R2 is also 2 ohms. But effective resistance R is equal to 1 by R1. No, 1 minute. This is what? 1 by R is equal to 1 by R is equal to 1 by R1 plus 1 by R2, that is what? 1 by 2 plus 1 by 2. So in this case 1 by 2 plus 1 by 2 is nothing but 2 by 2. 2 by 2 is what? 1 ohm. Effective resistance is 1 ohm. So R is equal to 1 ohm. Okay, this is R is equal to 1 ohm. But voltage is same. V is equal to 12 volts. In both the cases voltage is same. Now we have to find ratio of power. Before we are going to ratio of power, we have to find what is the power in the second case. P2 is equal to, again what? V square by R. That is 12 square by R is 1. That is 144 only, because 144 by 1 is 144. Now power ratio is what? P1 by P2. That is what? 36 by 144. 36 by 144, which is 1:4. Powers in two cases ratio is what? 1:4. Hope you understood this well. Right, now let's see the next problem. Next problem is about 100 watt electric bulb is connected to 220 volts main power supply. Calculate the strength of the electric current passing through the bulb. So here what it is given? Voltage is given, one thing. Next what it is given? Power is given. We have to find current. So again, here also two problems we have. One thing we know, power 100 watt. One more, V we know 220 volt. We want current. Again which formula? I is equal to P is equal to I square R. You should be thorough in formula, then only you can do better. So here what we have to find? I we have to find. So from this what? I square is equal to power by R. So what? I square is equal to power formula is what? 100 by, okay, resistance also we don't know. So we have to find resistance. I square R directly we cannot use. What is the formula related to power, voltage and resistance? So we have to use V square by R, V square by R first. So what formula we have to use? V square by R, so that we can find direct formula we have, I forgot it. What? First formula, power is equal to V into I. From this we get directly I. Okay, no need to find out R here. So what is power here? 100 watt. So sometimes in exam you also make it confused. 1 second if you think again, you can recollect the formula and substitute. You should not get tensed. So power is 100 watt and voltage is 220. So we get I like this. In the first case, 100 by 220. After cancellation we get I, that is 5 by 11. 1 minute, let us write the formula first and solve easily. So I is equal to, from this I is equal to P by V. So I is equal to 100 by 220. After cancellation it is what? 5 by 11 amperes. If you want you can change that into decimal form also. You will get approximately 11 4s are 0 point. Directly we cannot. So what? It will become 0 0.4s are 44. 6 will be left. So again 5s are 55. Approximately 0.45 amperes it is. This is the current in the first case. Coming to second case, what? Again same formula. P is equal to V into I. From that I is equal to power by voltage. That is again I is equal to, in the second case what happened? In the second problem, same bulb, but it is connected to 110 volt. Before it is 220 volt, now it is 110 volt. So power is same, but voltage is different. Power is what? 100 watt only, but voltage is what? 110. So it will become 0 0 cancel. It is 10 by 11. After cancellation, if you do decimal, if you change that into decimal form, 0 point, it will become 100, 9, 99, 1 will be there, 1 will be left, 1 0 10 we cannot, so 0.9 approximately, 0.9 amperes. Hope you understood this problem also. Now next one, two electric lamps of 100 watt, 25 watt respectively are connected in parallel to a supply voltage of 200 volt. Calculate the total current flowing through the circuit. So here again in this what it is given? Power is given, both the cases, and voltage is given. We have to find out current. So same formula. Again what? I is equal to power by voltage, like before. From the previous formula, we know P is equal to V into I. From that we can write I is equal to P by V. So I1 is equal to, in the first case power value is 100. So 100 by 200. So that is what? 1 by 2, 0.5 amperes in the first case. In the second case, same way, I2 is equal to 25 watt by voltage is what? 200. So here what it is? 1 by 8. 25 ones are 25 8s are 1 by 8, which is 0.5 ones are, it becomes 2 means what? 2s and then 5s 0.125 amperes in the second case after changing into decimal form. This is what I1 and I2. We want total current through the circuit because they are connected in parallel. In parallel combination, total current is what? Sum of currents. So I is equal to I1 plus I2 after adding 0.5 plus 0.125, we get 0.625 amperes. This is what total current in the circuit. Hope it is clear. These two are clear. Right, now coming to the next. Here this is very important in our daily life also. How do we calculate the electricity bill? How electricity bill will be generated every month? That we have to know. This is related to the same concept. So here what power is given? Power of the heater it is given. And next what? How many days it is used? And one more, what is the unit? What is the rate of power per unit? Electric heater rated 100 watt, operates 6 hours a day. The cost of energy to operate it for 30 days. Okay, here one thing is missed, that is voltage. Voltage is also, it will be given. Generally it is not given because it is generally 220 volts in our home. Let us take it as 220 volts. Generally it is 220 volts. It should be given in the question. It is not given. If it is given, how to find out? Let us discuss. Now what we have to know here? Energy we have to find. What is energy formula? Energy is equal to power into time. Okay, no need to take voltage here. So no need to take voltage. Voltage is not required. Directly we can find out energy. So energy formula is what? Power into time. So power it is given 880 watt. 880 into how many hours a day? 6 hours a day. Like that, how many days? 30 days. This is what energy consumed. So how can we find out it? Multiply it. That is 880 into 180. Now 88 into 18. 64. Again 64, 670. Next, this is 88. 4, 8, 15. Then 2 zeros. So this is what? 15, 8, 4, 2 zeros. This is what energy consumed. Energy consumed is what? Watt hours. These many watt hours. But it is given 3 rupees per unit. What is 1 unit? 1 unit is equal to 1 kilowatt hour. 1 kilowatt hour. That means what? These watt hours should be changed into kilowatt hours. For that, what we need to do? Energy is equal to 158,400. This should be divided by 1000. We want to change that into kilowatt hours. Whenever you want to change it into watt hours into kilowatt hours, divide that by 1000. Now it is what? 0000. That is 158.4 units it is. Now it is units. Now cost will be what? Cost is equal to, because it is given 3 rupees per unit. So 3 into 158.4. That is 3 4s are 12. 3 8s are 24, 1 25. 3 5s are 15 to 17. 3 1s are 3 1 4. Somewhere we have done mistake. 1 minute. Yeah, 154. 158.4 by 3 into 3. 12. 25, 17, 3 8s are 24, 125, 2 3 5s are 15, 2 17, 1 3 1s are 3 1 4. Correct only. So what it is? 475.2 rupees. That is what the total cost per 30 days. Hope you understood this problem also. Now this is what, let us see this type of problems when there are parallel and series combination together, how to solve it. So here we have first two resistors in parallel. So we have to find out effective resistance of this first, then effective resistance of this also. Let us take this as some RA and this as RB. Okay, this is RB. You can take anyway, and let us take this is what, some RC. Okay, now what you know, RA, RB, RC are connected in series, but RA is what? First we have to find RA. RA 12 and 6, it is a parallel combination of 12 and 6. So 1 by RA is equal to 1 by 12 plus 1 by 6. So here what it is, 1 by 12 plus 2 by 12, which is 3 by 12, after cancellation 1 by 4. Therefore RA is equal to 4 ohms. Next, because 1 by RA is equal to 1 by 4, RA is equal to 4. Similarly, we want RB. 1 by RB is equal to 1 by 4 plus 1 by 8, that is 2 by 8 plus 1 by 8, which is 3 by 8. 3 by 8, so what we get, RB is equal to reciprocal of it, that is 8 by 3 ohms. Now RA, okay, this is, we have taken it as RC. So wherever RB we wrote, let us make it as RC, because in figure we have taken it as RC. So RC, here also RC. Now what we have to find finally, RA plus, because these three are connected in series, RC is equal to 4 plus 5 plus 8 by 3, that is 9 plus 8 by 3, that is 27 plus 8 by 3, that is 35 by 3, that is 3 ones are 3, 3 ones are 3 again, 3 6 are 3 6 are, so that is what, 11.67 ohms is the effective resistance between terminals A and B. Hope you understood this one also. This is about some important concepts, problems, formulae in electricity. Hope it helps you to write your exam better. Thank you.